Hello, everyone, again. And welcome. At the moment, we just have 4 attendees, but people are coming. We will wait for sure 5 minutes because I know people needed a break after the previous session. So take your time. We will wait for 5 minutes.
The silence is killing me.
Oh, you can speak?
I guess so.
It's good that we don't hear Luis screaming. We will unmute.
Well, it's a nice weather here. I don't know in Europe, but I guess it's cold right now over Europe.
Super cold, yeah.
Thought so.
It is
Almost
quite
zero.
cold, even in Greece. Yes.
Even in Greece.
We have a stove in the house, so yeah, it's a bit cold.
Wow. Okay. I just can't imagine cold with Greece. You know, for me it's like always the sun over there.
We have mountains that are snowed, that have snow like 4 months of the year. It's or even more actually. We have high mountains in Greece.
So you have coastline and high mountains.
Yes, actually in Crete also, where I am currently, it's an island. We also have coastline and high mountains, like more than 2,000 meters. Okay, for Peru, this is nothing.
And how are the roads to get into any village in the islands?
How are the roads?
Yeah, the roads.
I actually had
Dangerous.
a really,
Oh,
really
okay.
dangerous road experience in Greece this summer.
Really?
Yeah.
Right. Sounds like Peru.
I was like, oh, it's raining all day, so we will do a driving day. And then there was not
Right.
much with the driving day because all roads were like over flooded and broken, and we were can't go in any direction. Yeah.
Oh, okay.
Can
I
happen.
won't expect that. Well, that's part of the adventure, I guess. You know.
You did say that. Okay, people keep coming. We have 14 people now. We will still wait for 2 or 3 minutes. And everyone, you can say hi in the chat as always. And make sure when you send a chat message that you send it to all panelists and attendees.
So, John, you are using the Alfie, the Alfie, how do you say, bar?
It's my poor man's attempt at the Alfie beard. So for me, only this little bit in the middle grows. But Alfie's been giving me some good tips for beard keeping.
Okay.
So one day I might have a beard that's maybe equal in volume due to Alfie, but I'm going to have to grow for about 5 years to get to that state.
All it takes is practice, John. You'll be all right.
How many years has yours been growing now, Alfie?
Maybe 5.
5. And do you ever cut it, or
huh?
It's just, do you ever cut it, or that's just what it does?
No, it has to be carefully pruned. I'm just realizing that this conversation is being recorded.
Oh, great.
Yeah. I mean,
you don't want to give away your deepest, darkest beard trimming secrets, then.
No,
saving them for a best-selling book.
Closely regarded. You know, we'll communicate about it on encrypted devices.
Okay, I was thinking about starting, especially because it is getting late in some parts of the world. And hopefully even more people will join in the process. So let me start sharing. Do you see the PowerPoint now in full screen?
Yeah,
Yes.
we see.
Okay, perfect. So again, welcome to the Delivery Models Working Group session. I am Katerina Troullaki. I am the coordinator of this working group. And before we go into today's agenda, I will just introduce a bit more about myself and how I came to relate with small wind turbines. So my first experience with small wind was during my studies as electrical engineer, where I did my thesis on different magnetic material for locally manufactured small wind turbines. And we also constructed a ferrite magnet generator. Then during my master's studies, I focused on life cycle assessment methods and conducted a sustainability assessment for locally manufactured small wind turbines. And currently my PhD is on assessing the sustainability of commons-based peer-produced technologies, and I will explain this further in my presentation, how it is related with the wind empowerment community. And I am also in the board of Wind Empowerment for the last 4 years, first as a secretary and now as a communications position together with Guillermo. So just a brief overview of what this working group is about. And I suspect that a lot of you have asked yourself this question before, including me as well from time to time. So why to study delivery models for small wind turbines? The need for this working group came up with the recognition that small wind turbine systems are socio-technical systems, and for their sustainability, a variety of non-technical factors have to be taken into account. And by socio-technical, we mean also social, ecological, economic, institutional, cultural, technical variables. An example that we can give to explain how non-technical factors affect the sustainability of small wind turbines is that most systems fail because of inability of users to cover maintenance costs or the lack of capacity of the users to fix failures, or even lack of interest from the users to fix the failures because of no sense of ownership of the system. So delivery models is a term that has been used in energy access literature and could be described as the strategies that a project employs to overcome barriers towards delivering energy to users in a sustainable way. And here is a common representation of the delivery models concept. In the middle, we have the main elements of the delivery model, which comprise the key activities, the key stakeholders, the end users, as well as the resources needed, and the impacts, the costs and benefits of the energy system. And then additional factors that need to be considered when designing an energy system are the enabling environment. We talked a lot about that during the previous session, the social cultural context, and any additional supporting services that may be needed if the local context is not already favorable for the sustainability of the energy system. So we can say that the scope of this working group is the study of the complex system and the diverse actors that affect the sustainability of the small wind turbine system and the strategies to achieve this sustainability. So maybe now you have a more clear idea of what the delivery models working group is about, but just to complicate things a bit more, at the beginning of this working group, the sustainability of the small wind turbine system was referring to the ability of the technology to provide the energy services required by the end users. So actually the continuity of the energy service. But today, with the recognition of global environmental and social problems that we face, the concept of sustainability is broadening, and it is also related with impacts at planetary level. So we can say that we are aiming at solutions, at technologies that are both sustainable and convivial, meaning that they can live together with other human and non-human elements of their broader ecosystems. So I propose a wider scope for the delivery models working group by adopting a broader understanding of what sustainability of the small wind turbine is and interconnections at both the local and global level. With this scope in mind, we designed today's session. So today's session intends to bring together people working on a large scope of topics relevant to this working group and to kickstart collaborations among them. Also to revive this working group that has not been extremely active during the last years, and with an open discussion at the end, together with the market assessment working group, we hope to get a clearer idea of how the people's skills and interests can match the needs of the network, and how these two working groups presented today can better work together and inform each other. So today our session will develop in three parts. The first part with two presentations is about what has already been done in the working group, and it's basically conceptual works. Then three wind empowerment members will present delivery models employed by different member organizations. And finally, we will have two presentations on assessing sustainability impacts of small wind turbines. We will have a round of questions after each of these three parts. So please keep sending your questions in the Q&A box, and we will have the live session after each part. Okay, I don't want to delay anymore, so I will give the speech to Guillermo now to start his presentation.
Okay. Hello, can you see my screen? Can you listen me?
Yes, Guillermo.
Yes.
Perfect.
Well, hello everybody. It's a pleasure to be here and share this space with all of you. Just to talk about the Kickstarter project, this is just a brief, because during the next slides, we are going to talk about some discoveries that we did from this study. The Kickstarter project was the first study that we did in the delivery working groups 4 years ago, in the 2016. And was the objectives was investigate and systematize and analyze different delivery models in the work in Wind Empowerment members. So because we take the concept, when we start delivery models, we didn't know what was the meaning about that, and the concept was more related to management area. So the first thing that we have to do was resignificate the concept and adapt it to social projects or the development project with small wind turbines. So for that, we did a research study. We interviewed, we did 13 interviews for different working wind empower members. And we take the different variables and we did different interviews. And well, these one are the cases that we studied from all the world. So we can was a really good approach because we can understand different realities from different countries and different kind of projects. Include different projects doing by the same organizations. That was a first learning. There are one organization can do or can apply different delivery models in different projects. So that one are the variables that we identified. Actually, Katerina talked something about this concept, but the more important thing is that we relate and we resignificate this concept to social projects. That was the first learning. Well, the concept about delivery models, the first one is that Katerina read before, and that was the first one that we had. And after that, we was including other backgrounds in our concept. For example, I come from the social economy area, so I include that approach. Katerina, she's studying the life cycle, so she include that approach also, and we use the social technical approach that John Leary proposed. So until now, I think that we can have other concept. Katerina, this is good news. We have other concept from delivery models. It's a new one. But well, this we understand that the delivery model is the set of methodological, theoretical, and technical tools that come into action from the zero moment of implementation and define the relationship between the technology and the user community. I think that the main point of this is the moment zero. That means that we have to study before that the technology come to the community. At this time, just something is happening. So when you do the first contact, well, the project, your delivery model is running. So it's very important to understand that relationship. Well, we can. It's very interesting if you can read the final research that we did with Katerina. A guide for delivery models document is on our website, and in that document we identified the different variables and different successful and unsuccessful things in the different variables that persons that were on charge of the project told us. But after that, we try to understand more about from this information, and we think that this is just an analytical approach, so it's just an idea. But I think that we have different kind of delivery models in the work in the wind empowerment organizations. The three different models are this one. One of them is the one-way project model. Well, what's that? Well, this means to the projects that are not so related to a need access. It's more focused on demonstrative projects, you know, workshops or demonstrative projects that the wind turbine is not giving electricity to solve a electrification need. No, it's not a development project. No, this project, the main or the difference that have with the other ones is that is a very short-term project. So we don't actually, that is better if you plan for a long-term everything, but for this kind of project, it's just, for example, 1 week or 2 week projects, and after that, all the activities involved is more related to the end user. Yes, and what happened if the turbine is not working? Well, there is not a big problem because it's not related to a need electrician, no? So that the people is not without electricity. And the other two models is one is called the local external development co-management model, and other one is the community management model. What's the difference between these? Both of these delivery models are focused on the development projects. What I mean, in a very simple way, this project try to solve an electricity need. So there are different situations that you can do it. The main model that we can find in the Wind Empowerment members is this one, the local and external development or co-management model. What this mean? Well, the electrification need is not necessary in the community, and other organization, an external organization that could be located in the same country, in different countries, or maybe in the same region, but is not in the community. Well, that organization have the knowledge and the capacity to solve to give the solution, but have to do in far from the place the need is going to be solved. So these projects are development projects. The most of these projects are focused on development countries. The main characteristic is that it's a medium or long-term project. We cannot think a development project for 1 year. We have to think about 2 or 3 years at least. And well, the other thing is that the project includes a co-management local actor. The most of experience are off-grid, and so the experience are solving a need to access to the electricity. The financing, the money that you need is obtained for the external organization, and that financing is focused on the initial project. The project that we can find later is to the sustainability. Well, what the difference between the other one, the community management model? The community, well, in the other one, the last one, the local external, you can find, for example, experiences in 500 RPM, Guinea. The most of the project are like this one. And the community management model are, for example, the Scoraig experience, so the Hugh Pigot experience, or for example, the WindAid experience in Playa Blanca. Well, 500 RPM, I'm trying to do the same in Cholila. But what's the difference? In this case, is the same community. The community is solving their own need about electrification. There are, of course, there are other external actors, but all the capacity, the knowledge, and the tools, everything that you need is in the community. So it's the community that is giving electrification for themselves. Well, the main thing about this is that kind of model requires that we can find at least one person or a team that have the knowledge, but more than the knowledge, have the personal motivation to do or to carry out this topic, you know, about the energy in their community. So maybe the wish, you know, the objective, the main objectives in our projects is turn on the co-management model to community management model, no? But well, the question is how, and well, that as we are working. Yes, well, that is good. Some concepts that in the different kind of delivery models, the interviewees are told us what is which concepts or which variables is or dimension we have to take in account. For example, in the one-way project model, well, you have to prepare the suppliers and just the communication, and just if you focus on the workshop, it's okay. But in the other projects, we are talking about development projects, so to bring efficient and effective electrification service is not a very easy thing, and more if you are in a foreign country, so you have to take in account a lot of things. For example, the orange concept is the barriers that projects have. For example, well, the suppliers, because it's changed a lot, the materials and everything in different countries. The time, well, that we have to understand that different countries and different towns have a different concept about the time. So the time is relative. And this problem, the post-financing, is the most important problem, because in the development, what happened with the development project? We in the development countries, we have a lot of funds for the initial fund project, but after that, the community in the development countries that don't have a high social economic level to maintain or to well, yes, to be a sustainable system for themselves. And what happened with the community management model? Well, the problem is that happened in European or other countries where the community have the resource to buy the system or maintain the system, but well, the problem is that the most extended need are in development countries, no? Well, that's it. That's it.
Thank you very much, Guille. I think this was very useful to understand the different strategies that wind environment organizations adopt. Let's continue with Wanda's presentation, and we will have questions after that.
Right. Okay. Can you see the screen? Yeah.
Yes.
Yes.
Okay, perfect. So yeah, welcome to my presentation. I'm Wanda Klemm. I did my master thesis last year at the University of East Anglia and the cooperation with the delivery model group. And currently I'm working at a very small company in Dresden, in Germany. And yeah, it's about big, large wind turbine. Right. So in my master thesis, I was very much focused on this report, which was presented already, and also a lot of other literature around delivery models in the area of energy access. So it was also about hydropower stations and small systems which produce energy. Well, so I was trying to systemize all these different kinds of delivery models and to develop a concept which is usable for delivery for different types of projects. So what was presented before is like 3 types of projects, and I wanted to bring all together. So at first I wanted to try to find the differences between different delivery models. What are they neglect and what they contribute to the discussion of delivery models. And later on, I was focused on the key elements of small wind turbine projects, whether there are dynamics, roles, and actors, find universal categories of small wind turbine projects. So at the first, probably I can skip this, it was already mentioned. So a very typical start is in defining an enabling environment and supporting services which make a project possible. Another concept is also the ecosystem. So that says that every part of the system needs each other. We cannot neglect one of them. And then also what I really liked was the focus on participatory framework that says like also from the beginning you can include also in the research people who are involved into the project. So yeah, to see who are our partners and what they want and what kind of ideas they have. So in the end, we need a delivery model which is socio-technical. What I found, I'm sorry for a lot of text, but it's not so important to read all of them, is to say like the most aspects which were shown almost in every delivery model is like who are our actors and what they have to do. I'm sure the people who are working in the projects are also asking themselves how we do it, how we organize the maintenance, how diverse we create our funding construction, let's say. But it was not shown directly in the delivery model. So my finding was like, we need to present in the delivery models also the dynamics and the resilience of a project, or at least the question of how has to be asked when we start to assess existing projects or to develop new ones. And when we ask the question, then we find more about the dynamics of the project and the history of the project and why one of the projects are fail and others not, even though they are quite similar to each other. So let's go to the next. And then later on, from the literature of different delivery models in different contexts and different perspectives, I could find different dynamics which were explained in a more theoretical way. So one of them is like to find risks and the relations, to explain the character of a delivery model as a goal-oriented or process-oriented system, and so on. And the other finding for the second question was like key roles and key actors, where like donors, execution, research, and so on, which should be all connected with like ideal condition. So here, that's like the basic of the delivery model I developed. It does not say that you have all these components in every project, and probably often the users and the maintenance service can be the same person, actor, whatever. Just say this is like the basic structure which can be used for analyzing a project or to plan a project. So long-term funding is often like a critical question for projects, and from there, if you don't have the long-term funding, of course, then you can define your first risk of the project. Flexibility to execution is also quite important, to adapt all the time to change in the situation in the process of the project. Inclusivity of the feedback, so that you not have a, like only feedback, how is the manufacturer are improving. It also it needs a feedback to the donors, to the users, and so on. So all of this like ideal features which can be into the place, or you probably should work on them. So this is the delivery model I developed. I know it's quite comprehensive, and I'm sorry for this, that I wasn't able to make it more simple. But let's have a look into it. So here I have the donor part, which have like, yeah, I try to connect them with different aspects. So for example, the donor have the interest of fast development and a short intervention, or they have the interest of a pilot project. It's more like an experiment. So the first one would be more a goal-oriented process. The other one would be more, a process-oriented process. It does not say that one of them wrong or right, but it's like one description for category of the process. So there we have the execution part, research, the feedback, and each of them has, their different aspects which need to be into account. The users here as well. So I want to come back to the dynamics just to make it more clear what I want to say with it. So for example, the supply-driven character of a system could be mean that you have like a donor, you have an institution, for example, university. There are some students who are interested in small wind turbines. Then you have already the students who execute the whole thing, and then you go further, do some research, and so on. The other way would be a demand-driven character of a project, where you have like the users who need electricity and so on. So that's quite obviously, I know, but I think it's quite helpful to have this kind of categories to analyze projects. And here it doesn't say this is wrong and this is right, but it can tell a lot about the project and what are the weaknesses and strengths. Right. The other one would be the dynamic processes and dependencies. So here I took a table from Leary thesis on the delivery model on small wind turbines. This is like on the left-hand side is the environment, enabling environment. So this is the question of who is doing what, who are the people who pay for the whole system, and then you have like on the top all the tasks which need to be done. So this question are be answered with this table, but it doesn't show the dynamics of it. So here, for example, we have the government funds which cover the capital costs and almost all of the project tasks, and running costs are also paid by users. So here we don't ask how willing are the users to pay for a long time, and how much are they able to pay, and also how much we want to depend on the political will. Those are the questions we also have to ask. So I wanted to show my map what are possible risks and also how to minimize the risk. One of the minimizations could be to create a donor diversity, so include also other donors who, paid amount of the whole time of the project. And so this is the delivery model map again. And here I have the users part. So if you have a strong donor dependency or a high willingness of the user to pay, these are two aspects which you find. And if you have a donor dependency, of course, and then you have a strong dependency on them, and then you have a high risk that you probably can lose the funds you need. And then you have here again the ways of how to reduce this dependency. So another aspect I want to just show here is combinations of very extreme critical factors. This came directly from the case studies, and the one very critical aspect is like a combination of large distances. So it's like often a distance between an external maintenance service and the site where the wind turbine is. Low local technical knowledge, and also many environmental hazards. And the other one is quite similar. So if you have on the production side, a low volume of manufactured small wind turbines, low experience in manufacture, and many environmental hazards. So this is the legend for the read the delivery model map. So the star is for very desirable, then you have the risk, the combination. And I just wanted to go this part of the delivery model map, so the critical combinations of risky factors. So here we have again the maintenance service and the users. And if there is a large distance in between them, a strong dependency on external maintenance support and many environmental hazards, and you should be careful in implementing this kind of project. And yeah, I mean, I'm saying the same I said already, but just to show how to read the delivery model map. Well, and the stars again, on the user side, it's very desirable that you have a high responsibility for the turbine, and on the maintenance side that you have like a fast availability. Right, and the same we have here. Then second risky second combination of risk factors is if you have a low volume of manufactured small wind turbines, a low technical knowledge, and also many environmental hazards. It does not say that this like that in every project you will find all of this aspect, but it should help to go into the field and to ask different questions about the project. And probably in one of the projects you have just very small, or you can find very last aspect of this map, but it should, I try to bring all the different types of projects together so that you can probably develop your project or access to analyze your project and bring different experiences which are already in the field of small wind turbines together. All right, I think that's all I wanted to say. Yeah.
Thank you so much, Wanda, for this presentation and also your work to add the dynamics in a delivery model system map. Let's see if we have some questions for the last two presentations. I can already see a question from Luis to Guillermo. Luis asks, is there a link between the three delivery models? Do members go from one to another over time?
Yes, it's a very good question. Well, first of all, take in account that this is an analytical approach. So maybe in the real cases we can find mixed things. But it's important to focus on projects and not in organizations for this, because some organizations have different delivery model for different kind of projects for different purpose. For example, the one-way model is good to make workshops, maybe for fundraising activities and just demonstrative projects. And the other ones that have other different purpose. I think that in the second one, the co-management model, the main objective is to become a community model, I think. But that again, the question is how long term and which action we have to do for obtain that.
Okay, great. Thank you, Guillermo. Is there another question? I see again one from Luis. So if there is no other one, I will take this. So it is for all of us. Have you seen the UN document on microgrids for rural electrification? They talk about vicious and virtuous cycles on the system. So personally, I haven't seen it, unfortunately, but after the comment, I definitely have to check this. I don't know if anybody else from you have checked this and would like to make a comment. Okay. Did somebody?
Oh yeah, it was me, Katerina.
Okay.
No, I'd seen the same question of Louise in the previous session. I was just because I had a similar one slide where I mentioned about a vicious cycle. Unfortunately, it was not taken from that reference. It was purely an analysis done from our end user survey. But thanks, Louise, for the reference. It looks very interesting. I'll definitely have a look.
Okay. I have a short question to Wanda. Whether the delivery models map, if it is available in an editable format so that we can keep updating it?
Can you hear me? Yeah. Until now, not. So I don't know. I will try to find a way to make this possible. Because I think before, like, I had the idea to make it like bring it in a more simple form, so to make it more easier to read it also for people who are probably very new in the field of small wind turbines. But yeah, I'm thinking of this to do this.
Okay, it would be great to have access to edit it and add new elements and make changes.
Yeah,
it would be great. Okay, I think we don't have another question. No, we have one question from John Guillermo again. So what do you see as the key actions that can help us convert co-management projects into community management projects?
Well, maybe we can, how do you say, replicate Mr. Pigot and share Mr. Pigot for different communities, I think. No, actually, I don't know, but for this, I think that it's very important a long-term plan. I think that if you are become a community management, but that takes, for example, I don't know, but 4 or 5 years. We have in 500 RPM, we have an experience, you know, Nahuel in Cholila. Well, nowadays we can understand that model like a community management model. Well, it's becoming that model, but that takes around 4 or 5 years to sustain actions. Yes.
Okay, thank you. So there is one more question, but I prefer to keep it to the end because I know that the next panelist will have to leave us soon. So I want to give enough time for Gandhi to present and answer some questions. So we keep it to the end, Andrew. Thank you. So Gandhi, whenever you want.
All right. Thank you. Can you guys hear me?
Yes.
Okay, awesome. I will share my screen right now. And here we go. All right. Can you guys see my screen?
Yes, perfect.
Awesome. Thank you. All right. Welcome to my presentation. I just want to thank everyone to make this possible. This is an amazing opportunity. I'm representing WindAid Institute here in Peru. And during this this delivery modeling session, I will be presenting what we call the community aid. So first off, about my small wind CV, I have a degree in anthropology with focus in social project development and also in gender equality. In 2017, I volunteered for the first time at WindAid Institute. Then the next year, I became head of the community project development and an ambassador coordinator. And finally, in this year, I became a partner of WA International Peru. Woo! So this is the content of my presentation. And I will do a brief introduction about this presentation, starting by the history. So the community project development area started formally in WindAid by the end of 2017 and in the beginning of 2018 with a lot of support from many volunteers from different parts of the world. And it has two main objectives, which the first one is to study the social and cultural impacts of our work with local families. And the second one is to educate these local families about the importance of renewable energy, how they operate, and good impact for the environment that this makes. And jumping to the purpose of the area are three main things. One is to make a positive impact, of course. The second one is to educate about the importance of renewable energy. And the third one is to promote the use of these renewables. So, right, now I will talk more in depth about what this session is looking for. And we call it the community aid, and I split them into 4 phases. And one is the diagnostic of the community, which Basically, what that means is that during this phase, allow us to recognize and to understand what kind of community we are dealing with. And in order to do so, we have in here 2 bullet points that we do social and physical assessment in that community. I will start by talking about the social, which is basically this research about, for example, how many families do not have access to the electricity, what's their main economy activity, also if they tried already to work with the government in order to have access to this electricity. And so these are questions that we put to ourselves, and we recollect this information from our observations, having informal conversations with them, also having formal conversations, meaning interviews with these local families. And then we analyze and identify the problems they have and their needs. As well, other factors such as the politics, economy, social and cultural aspects. That's from the social assessment, but also at the same time, we install anemometer. I'm talking about the physical assessment. We install anemometers to recollect data of the wind speed in the area in order to know how viable is to do this project with the wind turbines, of course. And taking this social and physical assessment, this helps us to formulate, for example, strategies of integration. Like, what are the best days to work with these people? Which parties want to get involved in this project? Type of systems that we would like to install, you know, could be solar, could be wind. And how many families actually want to participate in this project. And also we can have, with all this information, an idea of a budget, how much it's going to cost this electrification project. And talking about the beneficiaries, these are families located in the outskirts of the cities. Usually composed of elderly adults and children. They have little support from the Peruvian government in receiving basic service. They dedicate more to a sustaining economy, agricultural or fishing. And usually they are very encouraged to receive any kind of help and also collaborate with what they can. So this is the next phase of the electrification projects, which is the execution of the project, or we call it make it official, you know, an official project. And once we collect all this data and analyze it, we decide if we put a green light on this and say like, okay, this, I think this will work, so we can move on. And then we do this project official. And by what I mean by an official project is that we will take the new tasks involving these local families. And I divide them in 4. One is the creation of a wind board that is made up of members residing in the community that will help us to guarantee the monitoring of all the activities and responsibilities involved in the electrification project. Then we designate the technicians. These are, again, they live in the community, are members of the wind board, trained, and they are trained on how the renewable system operate and in charge to do any maintenance as required. Then we do a basic training that's focusing on the users of this renewable energy We teach them about the operation, the use, the care, the maintenance of their renewable energy systems. And finally, we do the maintenance fund. That is an agreement between the wind board and the rest of the users to create an economic fund aimed at the maintenance tasks for the renewable energies. And then before that, before doing this, the third phase, after finishing all these tasks with the community and feel that we are ready to move on, we do the installations of these renewable energies. And that's pretty straightforward. To install a wind turbine, it only takes between 6 to 7 hours. So it's basically the day. But before that, we do all these tasks. And then once we start with the installations, we do the follow-up, which is the follow-up, for example, to the wind board members. That means we follow up their duties and responsibilities. In order to do so, we give to the board members a questionnaire where they must rate their teammates in a scale from 1 to 4. 1 is the being very bad and 4 being very good. And they rate their teammates and how effective they have been performing their tasks as members. And after evaluation, the team will discuss with each member individually about the results they had in their performance. Then we do the follow-up to the maintenance fund. That's basically the list of contributors who are our users of the system is reviewed together with the treasurer from the wind board, and they see how updated they are with their agreement payments. And also we discuss the measures that the members of the wind board have taken, and if necessary, what changes or new measures should be taken to deal with defaulters, debt repairs, payment amounts, and so on. And finally is the understanding of the use of the system. We do also do a follow-up on that, doing the same methodology. Services are carried out to all users, including members of the wind board, about their level of knowledge and use of the system. Likewise, the doubts they may arise about it, and they are desire to have another training or any kind of workshop they would like to. And finally, we jump to the impact evaluation. That's a very important one. And honestly, this impact evaluation is, we do that from the beginning to of the project and also during the follow-up of the project, because these are basically studies that are carried out to understand what kind of impacts we are doing into these local families. So I will just take here in this presentation 2 examples. One is the effective of our slides. This is basically focused in the social and cultural aspect of these families, how much it changed after the installation of these renewable energies. Like, for example, what activities do they carry out thanks to the deadline? Do you wish you could do other things? For example, what other things? How long is the working day? Is that enough time to you? How much time do children study? What are your activities or sleeping schedules? All these questions we ask before the project, but we also do the same questions after the project because we want to see what differences have been made. But of course, we add new questions like, for example, how many appliances did you bought? Like a TV or stereo, I don't know. And finally is the satisfaction level. We also do that before and after, like level of comforts, security, economic and recreational. Again, in a scale of between 1 to 4. And in the end, I just want to mention the achievements we have so far, future projects. One is a Shoro. As you can see, we did some work already over there, social and physical assessment, and we have support from organizations and individuals. And Nuevo California is another community in the Highlands. We did, again, social and physical assessment. Luz del Sol is another one, the coastline, 2 installations so far, educational workshops, and physical assessment. So yeah, I hope this brief presentation satisfied all of you. I'm looking forward for your questions. Thank you so much.
We thank you very much, Gandhi. Do you have to leave soon? Because I can. Yes.
I can stay longer. Don't worry. Yeah.
Okay. In that case, there are some questions, but we can take it after John and Guillermo also present, if that is okay. So, John, do you want to continue with the experience from Scoraig community?
Oh, will do. Let me just share my screen. Can everyone hear me okay?
Yes.
Good. Okay. Can you see my screen?
Yes, we do.
Yes.
Okay. Great. As you can go back a slide. So yeah, many of you may recognize me. I was formerly the coordinator of the Wind Empowerment Association. And I'm currently a trustee. Previously, I had done a PhD thesis looking specifically at rural electrification with small-scale wind, which kind of led me into this pathway of engaging with different people around the world who are interested in seeing this idea of harnessing the wind for the benefit of people living in rural areas. I also continued that theme afterwards at the University of Sheffield, which is where the presentation I'm going to give today originally was designed for. Currently, I'm now working at Loughborough University, and I've shifted my focus now, looking instead at how energy is generated, instead of how energy is generated, onto how energy is used, looking specifically at the application of electricity for cooking. So, on to the topic of today, which is called Scoraig and accidental ethnography. So this is a word that I'm sure Gandhi and several others may be very familiar with, but many of you, like myself, having an engineering background, had never really heard of the word ethnography before I embarked on this adventure. And I called it an accidental ethnography because it wasn't the main purpose for which I went to Scoraig. I'll come back to this in a second. But the main question that I wanted to answer with this case study that I'd like to present now, which is why small-scale wind power had been so successful on the Scoraig Peninsula. The Scoraig Peninsula, of course, being the home community of Hugh Pigott, the designer of much of the technology used by wind empowerment members today. So my PhD started with an engineering-based research question. I was sat in an engineering department, but really by the end of it, it was much more focused on social science and people, understanding what the impact of this technology was on the lives of people. So I had originally decided to do case studies in global South context, Peru, Nicaragua, Nepal, and it was never my intention to do a case study in Scotland. So this really was an accident. This ended up being probably the most interesting case study of the entire 3 years of research. So this is Hugh Pigott, halfway up a wind turbine tower in one of his favorite places to be in the world. I went to go and take technical performance measurements of the small wind turbines that he'd designed, installed and maintained on the Scoraig Peninsula using data loggers such as the one you see in the bottom right here. But I actually realized that I was learning perhaps even more by being part of everyday life and understanding what role small-scale wind power played in the everyday lives of people. And this is really what ethnography is all about, immersing yourself in the context and understanding how different technologies or different interventions or different themes have an impact on the everyday lives of people. So really, this is what I ended up writing up and including in my PhD thesis in the end, trying to understand why small-scale wind power had been so successful in this one context, when in many of the other contexts I'd investigated it had seen many, many challenges. So yes, starting very much engineering focused and really ending up with a blend of engineering or social science. And I really think that actually that diagram on the right-hand side is not a fair reflection. It's actually much more towards the social sciences, what I'm going to present today. So this methodology of participant observation basically just means being a part of everyday life. I also used interviews and carried out techno-economic modeling, as we saw a lot of in the market assessment working group in the previous session, the market assessment working group. So the Scoraig Peninsula is on the northwest coast of Scotland. It's an extremely windswept location. It is not an island, but in many respects, it has a lot of similarities with islands, because this is the only track that will take you to the Scoraig Peninsula. There's no connection to the mains electricity grid or the water network, so it is very isolated. And in fact, the way that most people get onto the peninsula is through this small gap between the rest of the mainland and the Scoraig Peninsula across the loch on a small boat. So the Scoraig Peninsula has been inhabited for thousands of years. But the main recent settlers came down during the 1800s, during the Highland clearances. They were mainly peasants who eventually left because the lands were very barren, moved over to North America, and the peninsula was almost abandoned until the 50s, when a new wave of settlers came. These were people who'd left the mainstream society in the UK and wanted to live a more sustainable lifestyle. Hugh Pigott was one of these. So Hugh went about creating a new lifestyle for himself and for his neighbours on this peninsula, and had to meet many of the same development challenges that many of our colleagues in developing countries are facing, such as access to electricity. His neighbours became interested, and so he started solving the problem for his neighbours too, by building wind turbines for them as well. And people off of the peninsula also became interested. So he started taking people on tours to be able to understand how to use the wind to generate electricity, and then started writing a construction guide, which you see a very early version of here, produced in the 80s. This is what the Scoraig Peninsula looked like in the 50s, when it was basically abandoned, a very windswept and barren, inhospitable landscape. And this is what it looks like today. This is Hugh's very modern looking house with a small wind turbine in the background. So here's the question I wanted to answer. Why has small-scale wind power been so successful here? Well, there's many factors that contribute to this, but of course, one clearly is the magnitude of the wind resource. Scoraig is one of the most windswept locations in the entire world. You see by the red color, similar to some locations such as Patagonia in the southern tip of South America, but really there are a few other places that have as much wind as Scoraig. There are also very favorable environmental conditions. For example, there are very few lightning strikes, which means that putting power generation equipment on the top of a tower is quite a safe thing to do, relatively. In terms of economics, then looking at the levelized cost of energy or levelized generating cost in a context where you don't have many lightning strikes and where the wind resource is really good, it can provide a very affordable source of energy. One transformation that was underway as I was carrying out my research, most of it was done in 2012, 2013, 2014, was the arrival of solar power, which had been part of life on Scoraig since the 80s and the 90s, but really the price point of solar was becoming much lower and making it a much bigger part of the generation mix in many households, even on this household, which is on the north side of the peninsula. So in the winter, you don't actually see the sun at all for two months of the year. However, as you can see, you can't rely on solar for the whole year, and you could rely on wind, but it's actually much more cost effective to have a mix of the two in a hybrid system. So actually, most of the systems on Scoraig are hybrid systems. They're not wind-only systems. There's very few, if any, today actually that just run on small-scale wind power. There are some that have hydro integrated, but there's not much of a hydro resource on the peninsula itself. Many actually have diesel generators as backup or petrol generators, and most have at least one wind turbine, if not two, and also solar panels. Many of the systems have evolved over time. So it's not a case that they were built, designed and replicated in a cookie cutter style across the peninsula. They have been built according to the needs and the aspirations. So what individuals want from a system, what they want to prioritize, whether they want to prioritize reliability, affordability, or any other kind of existing priority of the users themselves, and that changes over time. So the key element here is that each system has evolved with the evolving needs and aspirations of the users. This is a photo from one of the kitchens in Scoraig, which really shows the connection with everyday life. So this is the battery voltmeter, which shows how much charge is in the batteries, and also the ammeter, so it shows you how much generation is coming in from the different sources. And this really dictates life for many people. In this case, if the voltage is above 13 volts, it means that they'll use the electric kettle to boil water for tea. If not, then it'll go into the stove, or they use a gas burner. So it's not that there aren't disasters. There are many problems with small-scale wind turbines on Scoraig, but a key thing is that you have someone there who, as Wanda mentioned, you really need someone who is not just capable, but also motivated to be able to provide maintenance services in an affordable and timely fashion to other community members. And of course, Hugh is the one who's able to do that on the Scoraig Peninsula. He's been living there for, it must be over 40 years now, and can walk to the furthest away household in 40 minutes maximum. So really, this is a quote which really, to me, epitomizes why small-scale wind power works so well on Scoraig. This is one of Hugh's neighbors simply saying, "It's Hugh." Well, maybe there's 1 in 100 people who could do what Hugh does, but the question is whether they have the motivation to actually get the work done. So this is testament to the tireless work of Hugh throughout many decades to find a solution which really works for not just him, but also all of his family, all of his fellow community members. So in this diagram that we saw in the market assessment working group earlier, and also in one of the other presentations, then we have all of these actors that are involved in the socio-technical system, but actually on Scoraig, then most of them are performed by Hugh, with the occasional support from other people, such as myself and other wind empowerment members. Of course, it's not just Hugh. There are also other members of the community who are really dedicated to providing these, to developing solutions that work and developing energy services that can deliver what people need in order to live a sustainable livelihood, such as this Scoraig community member who'd used a DC motor to be able to produce violins, which you could sell and earn enough money to be able to survive on the peninsula. So to conclude, then, why does small-scale wind power work so well for rural electrification in Scoraig? Well, the environmental conditions are right. Hybrid systems make them resilient. Hugh offers affordable and convenient maintenance services. End users are also empowered and proactive. It's not just Hugh. And Hugh is able to offer flexible system design and maintenance services, which really mean that what we see on Scoraig is this kind of far right-hand side of Guillermo's diagram, the community model, where this is really embedded within society. Hugh is there to respond and give feedback to people and to facilitate the evolution and co-creation of energy solutions that really work for people. Everyone is able to get live feedback on how their system is doing. And the economics really work in this context. Finally, local is absolutely key. So for locally manufactured small wind turbines, you also have to have locally available maintenance services and locally available support to be able to enable these systems to evolve with the changing needs and aspirations of the individuals. So thank you to everyone for listening. It's great to be a part of the active discussion within the wind empowerment community again. And I'm sure Hugh himself will be really happy to see that there's such a vibrant community that has grown up around the technology that he and the others on Scoraig had such a vital role in pioneering. So thank you to everyone for listening, and I'll pass back to Katerina and welcome any questions.
Thank you so much, John, for this big view into the quite unique case of the Scoraig community. And thank you for staying on time as well while giving us so much information. We have questions for you, but I will give the speech again to Guillermo to present about the 500 RPM strategy, and then we can take all the questions together for the 3 last presentations.
Well, hello again. Can you listen me and can you watch my computer?
Yes, to both.
Okay.
Yes.
Now, this is the delivery model presentation. My name is Guillermo Pleitavino. I'm a sociologist and I study social economy later. Nowadays, I'm working in 500 RPM in the fundraisings, communications, and like project development, different things. In Wind Empowerment, I'm in the executive board with Katerina in the communication area. And well, from 2016, I'm in the delivery model working group. So, well, during this presentation, I'm gonna focus in the 500 RPM experience and mainly in a productive use delivery model experience that we did. So it's gonna be focused on that. Well, about 500 RPM, I'm not gonna spend a lot of time. But you can research on the webpage, or you can see our social networks like 500 RPM. It's an Argentinian foundation, and well, you can see our vision and our mission is in the same line that Wind Empowerment Association. You know, the open source technology, the education, dissemination, social access to the electrification. Well, I'm not going to talk a lot about the technology, but we use the pivot turbine. And these are some of our impacts until now. From 2010, 500 RPM started to work in 10 years ago. And nowadays we have more than 60 turbines installed, more than 20 schools, rural schools, because one of the main projects is focused on technical schools and rural schools. I'm gonna talk something about that. Well, we have more than 40 social projects execute, more than 2,500 persons trained in different courses and workshops, and more than 1,400 end users, rural end users of the electricity. Well, where we work in Argentina mainly, but during the last 3 years, we start to work in other places in Latin America, and that is really good news for us. Well, the last year we worked in República Dominicana, Mexico, Uruguay, Paraguay, Chile, and we are starting some online courses in Peru also. About Argentina, we focus in different places, but mainly in the place where we can find wind. So the best wind in Argentina and is one of the best in the world. Is located in the Patagonia. So the most of our project is located here. And during the last years, we have a kind of a strategic vision to focus here, because in the Patagonia we have an extensive rural area and a really good wind resource. So here you can find a similar situation that John described in the Scoraig place. Well, that one's why I'm showing this our values and that kind of things is because when I introduced the delivery models concept and our theoretical approach, you can you can observe that in our organization that concepts are included also. So in our values is the technology, open technology, train the community and different kind of actors, the sustainability, they replicate our projects and involve local actors. We have different programs and projects. One is the rural development program, one educative program, and other one is to research and development new technology, but it's all related because we're trying to focus on the rural end user need. So all the technology or the solutions that we are creating is focused on that, and it's the same with this program. We work with schools and cooperatives, well, a lot of kind of actors. Well, but I mentioned here the productive use project because it's one, because I'm going to talk about the productive use projects and how I understand that we apply the delivery model over there. Well, first of all, to understand our delivery model background and our organization background, is very important to understand this concept that it was proposed by John Leary. Well, actually is a very important concept because this gave a lot of work for social scientists in this area. So thanks, John. Is good, but the thing discovered is that John observed that the technical and the human dimensions intervene in the or contribute equally to the sustainability in the projects, and that is a very important thing about this concept, the equally, no, because it's very usual to understand that the social aspects are less, or the technical aspect are the most important. Well, John understood that it's a mix. So for us, every rural system is a complex and a dynamic system where countless variables and technical and human dimension that contribute equally to the operation, to the system. Here is the graphic that John told us. Well, it's just to show you that the turbine and the community are the main thing, but it's one thing that between a lot of things that we have to take account if we are worried about the sustainability, no? And about the delivery models, well, I talked before, but is this how we can obtain the sustainability? But it's not just the sustainability; it's the sustainability with an efficient and electrification service. So that is our challenge. Oh, sorry. Yes, well, in the case of the productive use, well, this is the delivery models concept that Katerina and me, we are proposing. The main thing is to understand this, what we are gonna do until the moment zero. What is the moment zero? Include that the demand from the community doesn't exist. So it's the real zero moment. There is so the actions that we choose until that situation is going to be part of our delivery model. So in the productive use, first of all, I'm going to introduce you to the project. So if you understand a PIGOT system, like a social technical system, and if you had to include the delivery model concept, so you start to think other point of view. One of that was the productive use. So because before we have been focused on the electricity, but we never thought in deep about the productive use, for example, or how we can contribute to the local economic activities. So if you take in account if you see the system like a social technical system, so we are going to do that kind of things. So fair of all, so the purpose was how we can empower the small rural economies. So fair of all, we studied which economies or which activities we were talking about. So we did a very in-depth research, you know, about the needs, about the different things I'm going to show you, and see one of our objectives was increase the local economies, but that focus on the sustainability of our system, because like you know, in the development countries, the rural users, the rural economies are usually very poor, so they don't have a resource, not for the initial installation, not for the wind turbine and all the system that is really expensive, but they don't have money to the maintenance also. But well, that is a economic practice also, so we need to study that. Well, so what did we do? We identified 3 different economic activities. We try to the activities were the most representative activities in the rural areas. So we identified the horticultural activity, the egg production activity, and the rural tourism activity. That is one of the reasons, because and nowadays, like an organization, we can analyze projects in other countries, because the one of the main learning is that the rural situation is very similar in around all the world. You know, we have a small or very low capacity economies without access to the water, to the electricity, or to other rights and that kind of things.
Sorry to interrupt, just I will ask you to try to wrap up in the next few minutes.
Okay, yes, sorry. Well, and what about this kind of the delivery model that we did? Well, first of all, we did a really in-depth methodology. We did already 45 in-depth interviews with different kind of actors, and this is very important thing because we try to know in deep to the end user, but we try to understand the territory capacity. So identify the technical local actors and the financial local actors and other resource on the field was a really important thing. No? So, and we interviewed different referent persons that are referent in different areas. For example, in horticultural and tourism and the different public and organizations. And we applied a multiple dimensions. So if you take in account that, for example, that the system is a social technical system, well, you had a lot of variable and dimensions under study. If you consider that for example, the economy is a social economy, so it's not just number. So you start to understand and research a lot of things. For example, associative practice, the chain value of each activity, and that kind of things. That is the more important thing is to know that the methodological and your theoretical approach is very important. Well, after that, the other thing was identify the local suppliers and tool, and well, the communication and dissemination activities before start the activities on the field. The communication and dissemination activities is important to say that we carry out during all the project, like like a continuous activity. Well, the training and the installation, the monitoring the results, and well, in the incorporation of the improving and study the sustainability in a real sense. So this experience gonna work for how more time, and how it's gonna improve it. Well, after that we can talk more in depth about this. We have good result about the horticultural study. Is yes, nowadays we are expanding our activities on this field because, well, it's the main problem, you know, the access to the water. And if you focus on horticultural activity, you are focused on good health, food and practice to the family. So it's healthy food, is improve the economic capacity, and what there is a good potential if you use these technologies. This is very important to know. Every productive use project is a social technical system more complex than without the turbine, because economic practice is a very complex system. There is a culture things involved. There is it's difficult to change the practice, the cultural and the economic practice. So that is a good thing to take this in account. Well, this is in the result about the X production, good result, but with some problems also. I'm going to resume this because I'm going to show some interesting readings where you can research in deep about this. For example, you can understand more about delivery models and public policies with this excellent paper from John Leary and others. Is a really, I really recommend you to read it. Here you can find the productive use yes, the report. So here is very good to understand, because we have numbers about the production, about the water, about the relationship between the energy system and the water. And well, actually what we understood that the water is also energy in the field. So if you can storage water, you can storage energy. Well, but you can read this paper and this other also. This is a community project in Peru. It's very interesting. Well, the life cycles paper from Katerina, I think that is very interesting because she compared a commercial system and a pivot system, and that comparison is very important, you know, with tools, and that is the delivery model, guys, that you can find a lot of information about the different projects. Well, thank you very much.
Thank you so much, Guillermo. That was a great presentation. We have a lot of questions for all three panelists that have spoken, Gandhi, John, and Guillermo. Let's start with some questions to Gandhi. Gandhi is missing. Okay, he's back. So Gandhi, there have been a couple of questions about financial aspects of the WindAid projects. I saw that you already replied some of them from Emmanuel, but there's a similar one also from Guillermo. So he asks, how does the maintenance fund work in detail? End users pay fees. Any learnings that you can tell us about this process?
Yes, so regarding the maintenance fund, during the official project, you know, the training and getting all these members for the wind board, we try to understand what's more suitable for all the participants, meaning the users for the renewable energy. Regarding the payments, so what's more suitable for them to pay? Is it per week or per month? You know, like 30 soles, 20 soles, or stuff like that. So far, this is the methodology that we have been doing so far with these communities, like trying to discuss any agreement with the payments. But I know that to change that methodology into a use of this energy, you know, per kilowatts will be more effective, in my opinion. But we haven't done that yet. But this is something that definitely we will keep in mind to do so, because I think it's more fair in the end, depending how much energy you use from your system. But yeah, I don't know if that answers the question really.
Guille, do you want to add something to your question, or is it okay?
No, it's okay. That is, I just want to know because I think that we have the same problems. It's not so easy. It's not just the money, because it's very simple to explain. For example, one rural family in Argentina spent, I don't know, $1,100 a month, and that is a lot. Is a lot here in Argentina, but that they save that money if they use a wind turbine. But the problem is not just the amount, is how, you know, because they have other practice. So I don't know how to take the money because it's very far on the field, and yes.
Yeah, I agree on that. The problem is not exactly the amount of money, is how to do this regular payments. Because a very interesting example that I have regarding cultural aspects, the economy of this family usually depends on the season. You know, for example, season fishing, it's between, I don't know, June to August. So they have a very regular income. So let's say a lot of money for them. but let's say from November to January, there is no season for fishing, so they are like short in money. So that's a factor that we always have to consider, because definitely has an influence on all these families, and definitely have experience of families saying like, hey, you know what, I cannot pay this anymore. Maybe if we less the amount of money, and definitely is something that we gotta look at and fix it. And I believe doing this tracking of how much energy each family use will be ideal, in my opinion.
Thank you. I will continue with another question because we have loads of them. So again to Gandhi from Emmanuel, who makes the first move for community aid projects? Do you ask the community or do they contact you?
Yeah, that's a good question. I would say both. But the majority of cases, they look for us. Sometimes happens that let's say a local leader from the community that works in the city sometime hears about us from Facebook and send us a message and saying like, hey, you should look up the community where I live because they don't have electricity. This project sounds amazing, blah, blah, blah. And usually, yeah, they contact us, or from meetings that we have with other communities. They are also people from other communities attending those meetings. And they also ask us, like saying, you should visit our town also, you know. But also we do some visits during I don't know how to call it, like a period where from my area, we just go, for example, to the highlands, and because we have contacts, some people know communities where they work with because they are from the Peruvian government and they supply them food, for example, and they say, you know, I know this community, maybe you should look at these people and talk about them, about your project. So yeah, I would say both cases scenarios usually happen for us to make the first contact.
Thanks. There's a question from John to Guillermo and Gandhi. John, do you want to ask it yourself, maybe?
Was it a question or was it the answer to a question that was previously posed?
Oh, sorry. Okay, yeah. Perfect.
But I did just ask a question to Gandhi, and I could ask that one if you wanted.
Yes, sure.
But Gandhi, the question was, like, it's fantastic to see that I guess largely through your influence now there's so much more focus on understanding the development priorities of local community members and the local context of each community. But my question was, how often do your assessments find that small wind isn't the best solution for that community? You mentioned that it can become a solar PV project, but how often does that happen? And is that something that WindAid takes on, or do you involve another NGO or a private company at that stage?
Yes, so in my experience, I have in my mind one scenario, which is El Chorro, one of the communities I mentioned in the presentation. This community, we have been working with lots of individuals and also organizations, helping in taking all this data of the wind speed, but also social data. And we, thanks to a thesis from one of these individuals that help us, it shows that the wind speed, I mean, the installations of the wind turbines might not be the great solutions for this problem that these families have. So it also make us to believe that the solar energy is a good option for them. Because by the way, in Peru, the government, one of the things that the government says is that everyone has the opportunity to get energy from these solar panels. So the government is pushing that installations for solar panels because everyone has access to that kind of energy. I mean, everyone can possibly have access to that kind of energy. So once we understand that wind speed might not be the best solution, of course, we look into the idea of maybe just the solar panel, just to get the solar panels as a solution, or doing a hybrid system, which I will say we are more like to push for the hybrid system. Also because the wind turbines are pretty symbolic for us. And again, in case of El Chorro, they have good seasons of wind speed, but not the whole year. So a hybrid system could work perfectly once they don't have a good wind speed in some season. They will focus more on the solar energy from the panels. But yeah, does that answer your question?
Yeah, I think so. Thank you.
Cool. Thanks for the question.
Another question for Guillermo now, from Loic. What is the link between eggs and wind turbine electricity? Can you explain this a bit more, Guillermo?
Yes. Yes, the electricity is used just for light, for artificial light to complement the natural light. So if the chicken have more light, have more productive, are more productive, yes. So I think that we have an average between 15 and 30% more if we use light.
Great. Okay. And Jean asks, everybody, did somebody try pay-as-you-go as a delivery model in Wind Empowerment Network? So if anybody knows something about this, you can make a comment.
I think the only one I've ever heard of is Comet Me in Palestine. And I think they had some pay-as-you-go solar systems that were set up. And they've also included wind power in those as well. But I really don't know much detail about whether it was successful or not.
Okay, interesting. Next time we have to invite Comet Me to present the delivery model for sure. So another question from Luis, also to everyone. How do you handle information? Do systems have some automated alert that they have issues? Or is it only when the turbine comes crashing down that people realize that they have to do something about it? More specifically, how do you measure stuff and how do you convert measurement into data?
Yes, one important thing that is related with this question. For example, in our productive use projects, we have a local technical partner, is the INTA, the National Institute of Agricultural Technology. So that is very important. Well, of course, for the technical training, but also for the follow-up system. You know, if you want to have a good monitoring system about the indicator for productive things, well, INTA, they carry out they do that activity with us together.
I think from the Scoraig perspective, then I wasn't aware of any kind of automated monitoring, but there's definitely is a lot of manual monitoring. So both of individuals monitoring their own wind power systems, so simply listening to the sounds that turbines are making and watching them to see whether, for example, are they following the wind or are they jammed, and then taking preventative actions before a big failure occurs. So individuals monitoring their own turbines, but also because wind power is so embedded within the community, then monitoring other people's turbines. If someone knows that someone is not at home and they see their wind turbine, say, spinning out of control, then they will go in and they will put the brake on the turbine so that it doesn't become a catastrophic failure. So I think at that stage, when wind power is so embedded within the community, you have a lot more kind of manual ability to be able to know what is and what isn't normal operation. And that's something that can really help to prevent small problems becoming big disasters.
Yes, and just to add, here in Argentina, we are development. We are in process to development electronic system to protect the turbine. Is the Guillermo and the Electrical Laboratory of San Luis University, but this in progress also. It's an electrical system that if they can check some failure, well, stop the turbine or disconnect the most expensive electronic components, for example.
Great, thank you. I suggest to continue now with the next part of presentations, and any more questions we can answer them all together in the end. So Larissa, whenever you're ready.
Yeah, let's see. Maybe. Do you see my screen and hear my voice?
Yes.
Yes.
All right. Yeah. Hello from my side as well, and thank you for all that interesting information I already got in that session. I was thinking about that sustainability triangle while listening to your presentations and thinking of mine. We heard already a lot about economic and social sustainability. And now Katerina and me would like to speak about the environmental sustainability, I guess. My presentation is about energy efficiency and environmental impacts of a specific Pigger turbine at a specific site in Austria. That's me. I got my first contact with the Pigger turbine and small wind turbines in general in 2016. I was participating in a workshop in Germany. And after that, I decided I would like to have one at my university too. I did that together with Jonathan Schreiber from Pure Selfmade. And then it was also part of my master thesis, which was on failure analysis of small wind turbines in general. And thanks to John, I could compare my results from like other turbines to his results of Pigger turbines. Then in the last years, I was focusing on life cycle assessments, and also like Katerina did, we're analyzing the Pigger turbine and another small wind turbine in that area. And I'm a totally wind empowerment newbie. I got a lot of information from your homepage, but never been part of it. So this video is in the way. Yeah, I would like to give you a short introduction about life cycle assessment, and then, yeah, you will see, I will go to my work. What is a life cycle assessment? There is a general really specific definition of in a norm. I think the most important part is that it's about a product going to very different steps and analyzing all its environmental impacts in the different steps. And that could be toxicology, that can be emissions like global warming potential. It can be all kinds of impact categories, but it's always important that you start at really the mining, the raw materials. Then you have to look at all transport stations, the manufacturing, distribution, and really important as well, the end of life treatment of the product. This is the turbine. Oh, I have to find a way that the video is not in my way. This is the turbine we've been analyzing. We were building it in a university workshop together with Jonathan, who you can see in the picture here. He's from Pure Self-Made, and he was building the turbine with us, and we were installing it at the university site using that Venus controller over here. I actually, for my life cycle assessment, didn't perfectly use the design we used here, but changed to analyzing the generator he's building now. So with ferrite magnets and 16 poles and a diameter of 2 meters. So what are my research questions? First of all, is the turbine able to meet its intended need of renewable energy production? And to come to that answer, considering the whole life cycle, is the turbine producing more energy than it consumes? Is the turbine reducing greenhouse gases? And I compared that one to the ones of the Austrian electricity production mix. Which components of the turbine are hotspots? So which parts are the most have the most environmental impacts? And what design adaptations may reduce the energy demand and greenhouse gas emissions? Maybe I go fast through that slide. I think it's only interesting for people who do life cycle assessment themselves. I think an important point is to mention that I also included the end of life treatment, and then my functional unit. So always the system I'm speaking about is a small wind turbine system, which includes the turbine itself, but also tower and foundation and the electrical system. The inventory I did this together with Jonathan, who told me what materials actually used in the turbine, like he is building it. And the impact assessment I was doing according to that method, which includes, I think, about 18 different impact categories. So a lot of toxicology parameters. But then in my interpretation, I was mainly focusing, and that will also be the focus in my results I show to you here, the energy demand and the global warming potential. Performance measures we did over 1 year at that university site. And in the end, I was doing an improvement assessment, looking at what is the biggest contributor and how we maybe could change it and build the turbine in a more sustainable way. System boundaries, so what is included? I think this is quite important. Also, when we maybe later talk about the differences between Katerina's and my results, I think you, but we will hear it, had a strong focus on the operation stage and manufacture, maintenance. I just skipped it totally and had not included at all. I had the idea of that there is no more material needed here, but I had the mining, I had the manufacturing of the primary materials, I had the manufacturing of the turbine, the tower, and the electrical system. I had the transport included in all of this step, and the end of life treatment being part of my analysis. The performance measures were done at that site. The turbine was about here. It's a suburban site close to Vienna. We had an average wind speed of about 3.5 meters per second. Yeah, it was an isolated operation. Maybe it's also important to mention that the batteries have not been part of our analysis. Yeah, because we also use that secondhand. The data measurement was watt per second, so yeah, a measurement every second. And we measured an annual production of 363 kilowatt hours, which led to a capacity factor of 0.08. Yeah, probably it's really important before I show you the results to say that all the results we made, and I will show you, are really depending on this specific turbine, especially for the bigger turbine, who's always looking a bit different. Yeah, maybe you have a better capacity factor or a worse one, and then the results vary heavily, especially in the energy payback time, or you have a better or worse wind side, and then also, of course, the payback time varies a lot. So to my results, first of all, looking at the global warming potential, I divided the turbine into 3 subsystems. And as you can see here on the left, it's not the turbine itself, but tower and foundation who's contributing the biggest part to CO2 equivalent, so to the emissions of the turbine over its whole life cycle. And if you sum it up and calculate it over from the overall emissions to the emissions per kilowatt hour, we reach a total value of 93 gram CO2 equivalent per kilowatt hour. If you use that number and compare it to other numbers we have from other electricity generations or electricity suppliers, if I compare to the Austrian grid, which is actually a quite good grid when it comes to renewable energy production, we are at least lower than that with the bigger turbine, but still we are quite high. Oh, sorry. We are quite high if you compare it to, for example, big wind turbines, onshore wind turbines, or in Austria, there's a label for renewable energy, and also this value is way lower than the one I was calculating for our turbine. When it comes to energy demand and for, energy payback, these are also not the values I wanted to see and wanted to show. It's nearly 10 years energy payback. So the turbine has to be quite, yeah, safe, I guess, and should not break before she got 10 years old. So otherwise you can't call it a renewable energy production, I guess. Yeah, so I was looking deeper into how we could change that and reduce that. I found the manufacturing of steel being the main component, the main step or the main process where it all comes from. So the steel production is responsible for 45% of the emissions. Like only the steel production from tower and foundation is responsible for 45% of the overall CO2 emissions or CO2 equivalent emissions. And if you also have a look at the turbine, we have a total contribution of nearly 60% to the total emissions related to the steel manufacturing. So I think probably my biggest take-home message is to the ones of you building turbines, use secondhand steel or any other material, but don't use especially not primary made steel because it just has a huge environmental impact. So if there's any other possibility, you can really cut down your environmental impacts, especially when it comes to energy demand and to global warming potential. So in our case, if we would use second-hand steel instead of new produced steel, it would cut down the payback time from 9 to 4 years. At that specific testing site, of course, it will be faster at the more windy site. Yep. So my conclusions, when we go back to my research question in the beginning, when we are at the site with good wind conditions, small wind turbines like the Pico turbine are able to meet the intended goal of low carbon electricity production. The greenhouse gas emissions are lower than the one of the Austrian grid. Nevertheless, the energy payback times are higher than for other renewables, even at good sites. And the tower was identified to be a great contributor to energy demand and greenhouse gas emissions. And yeah, a really big potential to reduce the environmental impact is to get away from steel, or at least from primary produced, or also secondary produced. It doesn't change a lot because it's not the mining, it's the steel production. So secondary steel is better, but not that much better than primary steel. It's more than, yeah, I hope you get that. I mean, you can ask me if I should explain it more, this difference between second-hand steel, which is only just use a pipe again, or secondary produced steel, which is going through the whole steel manufacturing process again, but not through the mining. Yeah, this is all I wanted to tell you today. Thank you for letting me being part of that. And yeah, I'm ready for questions and looking forward to Katerina's presentation.
Thank you so much, Larissa. Great, there are questions to you, but I will ask to wait just a bit. So I also present and we can answer them after. Do you see my PowerPoint?
Yeah.
Okay, thank you. So I will give a very brief overview of work I have done within my ongoing PhD project. I will not focus on results so much that we have produced, but rather the approach that we're taking to studying the sustainability of locally manufactured small wind turbines, and I hope that this will spark some feedback and ideas for collaborations. So I carry out this PhD in collaboration with colleagues in the Technical University of Crete, the peer-to-peer lab, research collective in Greece, and wind empowerment members. I will start the presentation with how we look into locally manufactured small wind turbines as blueprints of an alternative mode of production. I will explain our initial approach towards sustainability assessment, and will refer to two applications that we have made. And finally, I will talk about the approach we currently have to sustainability assessment, and leave an open question for potential case studies within the wind empowerment community. So in this PhD research, we study an alternative mode of production that has been called as design global, manufacture local. The discussion about this mode of production has come up with the combination of the so-called global digital commons with local manufacturing practices. And by digital commons, we mean digital resources that are designed, developed, and shared and managed collectively within a community of peers, such as open knowledge, open software, and more recently, open designs of technologies. So combining these open designs with local manufacturing practices has enabled the production of globally developed technologically locally. So in short, DGML, Design Global Manufacture Local, describes the process through which design is developed, shared, and improved as a global digital commons, whereas the actual manufacturing takes place locally through shared infrastructures with local geophysical conditions in mind. And I just want to show here how such an emerging mode of production is consistent with the latest strategies from the United Nations Environmental Programme, and specifically the combination of global technology and decentralized solutions. So some cases that we look into as blueprints of this paradigm of production are communities developing open source agricultural tools that can be manufactured in local workshops, communities developing open designs for 3D printed products that can be manufactured at home or makerspaces or fab labs, and of course our wind empowerment community that is developing open designs for small wind turbine technologies that can be manufactured locally. This is the main research question guiding this research. What is the sustainability potential of such an emerging mode of production? So first we investigated how we will conduct a sustainability assessment. In sustainability assessment, the most common way to measure sustainability is through the simultaneous consideration of impacts in three thematic areas: environment, society, and economy. This sustainability model, also known as the triple bottom line, is basically a broadening of the usual bottom line for decision making in corporate environment, which used to be profit maximization. So along with that, the triple bottom line calls to consider also environmental and social impacts of decisions. So this model today has somehow become the holy grail in sustainability assessment, but also not lacking some criticism against it. Among the most common methods for sustainability assessment are life cycle methods. So environmental life cycle assessment that Larissa talked about, life cycle costing for the assessment of costs, and social life cycle assessment that is now developing for the assessment of social impacts. And these three methods combined have been proposed as a life cycle sustainability assessment framework to holistically assess sustainability of products, technologies, or systems. And it is also a common practice that multi-criteria decision analysis methods are used to integrate the multiple indicators calculated with the life cycle methods and the preference of multiple actors on these criteria. However, this LCSA framework is not defined, it is developing, and this research from the beginning intended to both apply and contribute to its development. So I will very briefly refer to two applications that we have done to assess life cycle impacts of locally manufactured small wind turbines. The first is an environmental life cycle assessment of locally manufactured small wind turbines and pico hydro plants. And the second, a combination of life cycle assessment, life cycle costing, and social LCA to comparatively assess a commercial and locally manufactured small wind turbine under different delivery models. So in the first case, we have considered all the stages of the small wind turbine life cycle, from production of materials to manufacturing, installation, operation and maintenance, and end of life. We also included in the assessment all the components of the system, such as the wind turbine itself, the installation materials, the electric components, and the electronic components, such as the rectifier, the charge controller, the diversion or dump load, the batteries, and inverter. And we assessed several impact categories with LCA. So the small wind turbine that we assessed was a 3-meter diameter pigot turbine manufactured and installed in a rural site in Ethiopia in 2015 as part of a collaborative wind empowerment project. We considered the 3 wind speeds, the real wind speed at the site, plus 2 more, 4 and 5 meters per second. And here are the basic parameters that we considered for the maintenance of the small wind turbine. So we assumed an annual preventive maintenance and 3 scenarios for corrective maintenance with 1, 3, and 5 failures in lifetime respectively. So I just share a snapshot here of the results to explain how this can be read. In each of these columns here, you can see the impacts per environmental category. For example, in this column is the global warming category measured in emitted CO2 equivalent per kilowatt hour produced by the wind turbine. And with different colors, you can see the breakdown of impacts from different components. For example, with yellow color, we have the fixed parts, the installation materials, the tower and foundation. And with green color, we have the electronic components that have quite a serious impact compared to the other components, if you see. And the 3 columns here show the results for the different failure scenarios. So 1, 3, and 5 failures in lifetime. And we also performed the sensitivity analysis for the total impacts by changing the average wind speed of the site. And the main insight here was that the number of failures does not influence the system's environmental impacts as much as the wind speed of the site does. So the wind resource and the consequent electricity generation of the wind turbine is a more significant factor than the number of failures for the system's environmental impacts. We see how impacts drop significantly as wind speed increases. So I know I presented it very fast, but I invite you to take a further look at our results that are available online, or if you don't have access to them, please contact me and I will send it to you. And the other case I wanted to share was a combination of environmental LCA with socioeconomic assessment to compare a commercial and a locally manufactured small wind turbine under different delivery models, basically different maintenance schemes. So we studied again the same 3-meter diameter Pigo turbine installed in Ethiopia in comparison with the Berge XL1. And we combined each small wind turbine with a different delivery model. And the first one was more participatory, including training of local technicians to conduct the maintenance, while the other delivery models assumed that maintenance services are provided by a small wind turbine business in Ethiopia at a distance of 140 kilometers or 600 kilometers from the installation site. So in total, we compared 5 alternatives, 3 of them with a locally manufactured turbine and 2 of them with the commercial wind turbine, and with different assumptions for operation and maintenance for each one. And here are the criteria we considered for the sustainability assessment. We have environmental criteria assessed with the life cycle assessment. We have a technical criterion of availability, 3 financial criteria, 2 socioeconomic criteria, local to national labor rate and national to total expenses rate, and also an institutional criterion that was used to estimate the difficulty of employing the particular delivery model. And we assigned weights to this criteria, but as this was a hypothetical example, different weighting schemes were tried. For example, equal weights to all categories of criteria, or an emphasis in economic criteria or social, etc. And using the performance of the alternatives on the criteria and the weights as inputs, we applied multi-criteria decision analysis and ranked the alternatives from the perspectives of two groups of stakeholders, policymakers and investors. Again, I invite you to contact me if you want to take a further look in these results. Sorry. So this one is not available online, but I can send it to you if you contact me. And finally, I just want to share that we currently have an updated approach to sustainability assessment after studying current trends in sustainability science. And we have identified some limitations in the life cycle sustainability assessment framework. For example, this framework is not transparent about what values are considered for sustainability. Sustainability is not a rational parameter, so an assessment needs to transparently explore what ethics and values are behind the conceptualization of sustainability. Also, life cycle assessment calculates aggregated impacts at global level and neglecting the spatial aspects of where impacts exactly occur. It is also blind about the interconnections of variables that lead the local system to sustainability, as it focuses on impacts on the external global system. And finally, the social analysis and institutional analysis in life cycle methods is still weak. And this is why we are investigating more methods, and we have been applying them for the moment in other case studies, land small wind turbines. Such tools, such methods can be the systemic tools used for delivery model studies. For example, the dynamic delivery model map that Wanda shared, or the small wind turbine ecosystem map that John has created. And we also experiment with the matrix of convivial technologies, which is a tool that is transparent about sustainability values and is used to assess the conviviality of technologies developed by grassroots communities. We are currently looking for a case study to apply this new set of tools for sustainability assessment with a participatory approach and an action-oriented approach. So I'm open for ideas about whether this could be found within the wind empowerment community. We're basically looking for a community of actors interested in using sustainability assessment as a decision support tool and a learning process. And some of the questions that such a sustainability assessment process can help answer are: what are the strong and weak points of the technology we develop? Where should we focus our efforts? Which technology or delivery model should we choose to deliver energy to our community? Which technologies or delivery models should we support for rural electrification? Or how can the technologies we develop, use, support, contribute to a more sustainable future? I hope I haven't given you a headache with saying everything so fast. Thank you very much for listening, and please contact me, my mail, or the delivery models channel on Discord to discuss these further. Okay.
Thank you, Katerina. It was really interesting, and I also see that I really like the discussion who already started and what the people ask and write, and especially that you all directly think about wooden towers, because this is the thing I'm always thinking about too. Yeah, I mean, maybe I can give that question in our round here. Do any of you has experiences about the use of wooden towers? Because from the environmental perspective, it would be great.
I think Mark already has written in the chat that they have developed a design for...
Yeah, the Swedish design, I know that one, but it's super expensive and it had nothing to do with do-it-yourself, low-budget production, I guess. It's more high, fancy, super expensive small wind turbine stuff. But it's nice.
Jessica, I give you the speech if you want to make a comment about this. I see that you have raised your hand about this. And also maybe Marco wants to make a comment.
Sorry, I didn't mean to raise my hand there.
Okay.
But yeah, no, the comment was that we did do an application like this in India, and then yeah, I was given the floor to Marco actually, and he is here, so he can talk about that actually.
Sure. Yes. Please, Marco. Yes.
Guys, can you hear me?
Yes.
Okay, great. Awesome. Hey, Larissa. Yeah, no, thanks everyone for the presentations. Awesome. Yes, we did a few projects with the wooden turbines, wooden towers, sorry, for wind turbines. We did a couple of towers in Brazil. One was just 3 meters just for a trial. Then we did a couple of years later a big tower of 15 meters high. And I believe we did in India, it was, I think, about 6 meters. So it's a modular design. It's can be done with the multiple type of wood. And obviously, we just try to use the wood that it's locally resourced. And obviously, depending on where you are, the cost is different. But in Brazil and in India, our wood was available quite cheaply. We could build a tower for about 50 euro module. So 4 module would be 15 meters high for 200 euros. So that's kind of I guess cheaper than the Swedish design that you were mentioning.
What about like technical issues? Would you say that it's something like, did new problems arise by using wood instead of steel, or do you have steel experiences at all?
Yeah, I mean the concern with wood is obviously the durability. We didn't test that. We really didn't have a field to test for how long and how often it needs to be maintained. Obviously, wood can rot, and if you don't treat it properly, and it needs more, that's kind of the maintenance aspect. The other thing is that it's quite, I mean, the design we tried, it was quite heavy. So although it's good because you can dismantle it and transport it, yeah, it was, when it's actually finished, it's quite heavy to lift. Heavier, definitely heavier than normal gas pipe that you use for the normal towers, steel towers. So lifting, yeah, and installation procedures are quite more complex. And the other thing is, yeah, from my point of view, is the assembly takes much longer, obviously, because where gas pipes we weld and it's quite fast doing that. Obviously, with the wooden tower, we had to assemble hundreds of screws and metal connections that that could also give weight to your sustainability assessment, because there is steel there, and for the screws and obviously the connections. So that's also something you need to take into account.
Let's go to the next question for Larissa. So Luis says some students in the university have used recycled concrete on the foundation. Does this mean the wind turbine is greener?
Greener than what is the question? In our application, we didn't use any concrete, so probably not greener than that, because concrete is pretty bad as well. I think, I don't know, I think most of you don't use concrete fundaments at all. I don't know. That's what I learned. I think that's a good thing to do. when it's possible, don't use concrete. And if you use concrete, of course, it's greener if you use it recycled.
In my case study, the wind turbine had used concrete actually in the installation, yes. Okay. And it has quite a considerable amount of impacts. It was a lot of concrete as well. So, especially
so it was
for the
like a real
warming.
concrete fundament with no ropes or something, but only a concrete.
It had both ropes and concrete, okay. Maybe too much safety.
Super safe.
Can I add something? No, yes. That I found really interesting your paper, Katerina, your presentation, Katerina, and your presentation, Larissa, because I think that it's very important put in numbers the things that we are thinking, because if we think the delivery models working group or the delivery model approach focus on public policies, I think that we have good learnings to bring to the public policies in the rural electrification area. So it's very important for the policy makers have studies like yours, because they like numbers. So I think that that's good.
That's true.
Okay, another question from Adrienne to Larissa. Have you calculated an estimation of the economic disease or environmental, the return on
I think
environmental? Yes, the return on.
Oh no, I thought it's energy return.
Energy, yes, energy return on investment.
I didn't use that thing, but I used the energy payback time. I think it's kind of the same and the opposite. Like it's calculated different, but I think it gives you the same information. And I think you can calculate one from the other. So yeah, one is, I think, the energy delivered by the energy used, and the other way around. So yeah. By now, I can just offer you the energy payback time, but I think it's pretty easy to calculate it the other way around. Yeah, and Jonathan, I thought in the chat, and he already told me before that I should mention our 9 years of energy payback time is really depending on the turbine, and that is not like perfect, like that. Yeah, the generator and the plates don't perfectly well fit to each other, so that we had this quite low capacity factor, and if our turbine, or hopefully most of the other bigger turbines, are more how you say, more efficient, like technical efficient, then we would also have better payback times. But of course, it's a self-built turbine, and maybe they are not, and maybe even worse. So yeah, I mean, yeah, I just wanted to mention that it can really change depending on the technical efficiency of the turbine and yeah, how it's built.
And Larissa, maybe it's useful here if we explain why sometimes the results vary. For example, if people compare mine and your results, they are not exactly the same. Mine are quite higher, I think, for the small wind turbine. So maybe you want to have a comment on this as well?
Yeah, I think a lot of it was already mentioned, so that it really depends. It depends on the production on the one side. So production always means, is it like the technology, technical efficiency, but also the site. We heard a lot today that it all depends on how windy is your spot. And on the other side, we compare it to the energy which is used in the whole process. And I think there were already some questions in that direction as well. What is part, like what are the system boundaries? What is part of our analysis? And I think there was a question from John about that too. Or I know I have read something about it. Yeah, for example, that I didn't had the batteries being part of the analysis. When I had the batteries, like when I was thinking of buying new batteries and being part of my system, my payback times would have been way higher. And all the same, I found it really difficult to find numbers or think of numbers for material used in while operation. So I did not integrate materials used for operation because I was thinking actually about, I mean, maybe that's because I don't that much into real practical experience, but I thought the material is really not much. It's maybe a lot of time you have to invest, but not much material. So we're just thinking of letting it out of the whole process because its contribution is so small. But maybe it's not. You never know if you don't integrate it. So yeah, I think it really depends on what is part and what not. And because this was another question, the electrical system, like the inverter, for example, was part of my analysis. So yeah, the batteries have been out of the system, but the inverter and the cables and stuff have been inside the boundaries.
Okay, thank you. Just to add to this, I think the most important factor is the wind speed. This is what I saw in my study. So I don't remember what wind speed you had at the site.
3.5 or something.
Okay, so it was similar. And in general, the production, the generation of the wind turbine in kilowatt hours is important because the results are calculated per kilowatt hour. In my study, I included the batteries, and they're quite a large part of the total impacts. And also the concrete was a large part, which was also extra. So these things can justify, I think, some of the differences.
Yeah, and maybe to add, because I think both of us compared it to other small wind turbine. If you talk about small wind turbines, we have that really big problem that it could be mainly, like it could be anything. They are so super different in material they use, in energy efficiency, in technical efficiency. So yeah, it's really important to define the specific system you look at, because I mean, ours already differ quite a lot, even though we talk about kind of the same turbine. But if you then compare it to a ducted, aged plate, whatever turbine, it's completely different again.
Yes. Also, a quick comment about the wooden tower. I just want to say that it is not really straightforward if a wooden tower will have low impacts, because, for example, in my results, the wood in the wind turbine blades, for example, and in the manufacturing of the wind turbine doesn't have a neglectable impact. So if the amount of wood in the tower is a lot, maybe the difference is not huge. And so this is something to study further. Okay, I'm trying to look into the rest of the questions. Maybe Kimon also you can help me, because I have lost track a bit after my presentation. So if you have found out some questions unanswered, please let me know.
Yeah, I just see one question in the to me about if my study is somewhere to find. Not yet. I'm just trying to get it in a magazine. Like, we will see if we have it in a journal soon, hopefully. Yeah, and I don't know if you want to have a maybe small report for the Pico turbine on your side or something. We can talk about that if that's interesting for you to have the specific results, because my paper is more like it's about both turbines, but it's not that in detail for the Pico turbine. But not yet. not yet published. Can I somehow say that the questions are answered? Because I think all from the Q&A are answered.
Yes, we can dismiss them if they are answered already.
Also, Katerina, I've copied all the questions if that may be useful in the future.
It's useful now also. So if we have some questions left, I guess we have.
Yeah, I think most of the most are comments and like good ideas. Good idea to have a new tower, a new turbine on an old tower with recycled foundations. I don't know if it's a good idea to laser cut some refurbished steel. We had to make an analysis about the impacts of how energy intensive the laser cutting is for that, I guess.
I see Bram asks about the price of wooden towers, if we have an estimation. I don't know if you know, Larissa, or maybe Marco also has a comment on this.
There's also something written there. Yeah, Marco already wrote again that it's about 200 euro like for the system he is using. But I think that's also relating really heavily to the site where you build it and to the local prices. Then somebody wrote, we have a massive wooden tower in Berlin made out of larch. It's around 5,000 euro, but has official structural analysis to officially build it up in Germany. Yeah, so yeah, German tower, German prices, I guess.
I also see this. Oh, sorry.
No, go for it.
Sure. Okay. A question from Luis about how much the power electronics play in the payback time and the impact. We kind of already answered this, I think. In your thesis, it represents about 22% of failures. In my case study also, depending on the impact category, it represents a different percentage. For example, in the acidification, it is by far the most impactful category, the power electronics. But just let me see. Oh, actually, no, it's the batteries. Sorry, it's not the power electronics. The power electronics have, yes, 22% is similar to my results. But again, it depends on the impact category. The cables also have a significant impact in the case of eutrophication impact category, the copper in the cables. So, okay, Kimon, if you have identified.
Yeah, I just saw a question which is referring to my master's thesis about failure analysis. That's really nice to see. It's important that we don't mix up failure analysis and life cycle assessment because electronics and their impact play an important role in both. I think what Luis cited here is I was looking at how, when looking at different failures and how often an electronic failure is responsible for an overall failure of the system. And yeah, but this is like a totally other analysis and has nothing to do with how much the electronic system is the word I'm missing. I'm talking too much. What it contributes to the emissions a turbine has. So life cycle assessment and failure analysis are two different things. And I'm not sure what direction the questions should go because
Larissa, did you already answer whether your analysis is available online?
Yeah, not yet. I'm trying to get it in a paper.
Okay.
Maybe you have some good input for me where I can send it to.
So there is a question I see.
Somebody posted a link, but I think that's my master's thesis, not my LCA study. I will see.
I see a question from John.
No. Probably exactly. Yeah, that's my master's thesis.
So there's a question from John. If I based my analysis on how much energy was generated or how much was used, and this is a very good question. You caught me here because I didn't mention that the kilowatt hours was at the output of the generator. So it didn't account for the losses in the cables or the power electron or the resistance, I mean.
Also, I guess it ties into the whole aspect of delivery model, as in how well the generation of power is matched with the utilization of power. For example, if you have an irrigation system, say, and it's very windy in the rainy season and not very windy in the dry season, then your factor there will decrease by quite a lot, the energy generated versus the energy actually used.
Exactly, because if the energy is useless, the point is the useful energy. The impact per useful energy would be a better criterion to assess the impacts. Yes, you're right. It's a bit more complicated to assess this, but it's very useful. I'm sorry for the delay. I'm trying to read through the chat for more questions. There is a question from Liz to John, actually. How about expansion? How does it play out? Not sure what expansion of what.
Yeah, I'm not sure I can answer that one without more information.
Yes, Liz, maybe give us some details. Okay, maybe it will be more effective if we already give the speeds to everybody, because we will continue with an open discussion anyway. So if there are some unanswered questions, please go on and ask them live. So Kimon, can you help me to unmute everybody?
Yep. Hi, can you hear me?
Yes, Luis.
Hi, I just wanted to ask for John about expansion. How does it work? How does it play out? Is it because the microgrid allowed people to get more revenue, so then they could get an expansion, or is it that something else has driven them to expand their installation? And how does that expansion play out in terms of the legacy system that is built upon? Do they have to just add more stuff modularly, or sometimes they have to rewire stuff and they have to kind of repurpose part of their installation?
I'm not sure I understand the question. What do you mean by expansion? And in terms of microgrid, are you referring to Scoraig? Because in Scoraig, all the systems are isolated systems. They're all household systems.
So I saw in your presentation that you showed some of the microgrids. Scoraig, people added more wind turbines over time. You could see there was a timeline and things were added over time that the microgrid expanded over time. At least the different households had kind of like different histories of how they're added more generating capacity. That probably means they had more load, but how's the process driven, at least from what you observed, or if other people has observed that as well in the field, this process of expanding the microgrid over the years because there is a more need for more power?
Okay, so in that sense, none of them are microgrids, with the exception of maybe Hugh and his daughter's house that are linked together. They're all individual systems, and sometimes where something new has been added, it's to replace something old that has broken. But yes, sometimes it is to meet a growing demand. For example, if a household gets a new appliance, say someone gets a washing machine, then they're going to have to increase the power generation to meet that demand, or think more carefully how they can manage the power that they've already got. So yeah, in most cases, that power demand has gradually grown over time, and through kind of regular conversations between Hugh and the other community members who he's talking to regularly as being a part of the same community, not necessarily having to visit as a say a business or like a formal visit to ask these questions, just maybe stopping in the street and chatting to someone and hearing that they're having trouble managing the power that they've got, and realizing that there's a need to be able to either increase the amount of power coming in, or to be able to change the way that that's used. For example, perhaps adding more storage, or perhaps encouraging someone to use the appliance at a specific time of day. For example, using a washing machine on a day when it's very windy, instead of, if someone wants to use a washing machine at any time, maybe they need to add more power generation or more storage. But if they're willing to adapt their behavior, that can perform a very, very similar role at much lower cost. Does that answer the question?
Kinda, yes. So, okay, well, I'll stay at that. I could reiterate, but I think other people have questions as well. But I'll come back to you. I'll get in touch with you on that, because we're working on this here in Toulouse and got a bunch of questions. If other panelists have seen microgrids expand, I'm really interested in that.
Anybody else wants to ask something before we move on the discussion about the next steps of the group? Okay, we're actually 1 hour late, I think. So maybe it would be good to continue with the discussion together with the market assessment working group. So we can use the Framemo platform. I will share the link in the chat with everyone. To add some notes that may help the discussion. And I can also share my screen to show this. Do you see the Framemo screen?
Yep, we can see Katerina.
Yes, yeah. Okay. So, okay, this is a joint discussion with the Market Assessment Working Group, and we have 3 main questions. The first column is to add notes. You can take a note from here, write something, ignore the friends, just double click and you can write something. So add, if you are working on a relevant topic with what we have discussed today in the 2 sessions. And then we can add on the second column about what knowledge and tools are needed in the field, again related to the discussed topics, so that now or later we can do a matching of what are the skills and interests and what are the needs in the community. And then we also have an open question about how the two working groups, delivery models and market assessment, can better collaborate, and what are the similarities and differences of these two groups. Alfie, maybe you want to add something to this?
Sure, I've been adding notes before I forget the comments I'm thinking of. So yeah, if any of you had joined the market assessment group previously, I've mentioned that there is an obvious boundary between what we do in the market assessment working group and the work done in the delivery models working group. It's a little bit more complicated than this, but one way I can think about this is, in some senses, the market assessment does the diagnostics, and then the delivery model comes up with the cure almost. You know, that's one way that I'm thinking of the relationship between the two groups, but others might have different opinions. I think something that would be useful for this discussion is to start to define how the groups could and should interact. I think in history we have interacted, but maybe not as closely as would be useful. So it would be good to hear the thoughts of anyone here on how we could improve in that.
So maybe in the graph I said before that delivery model is related also to the enabling environment, the sociocultural context, and the additional supporting services. I believe that market assessment can offer a lot of information in the enabling environment, and also maybe a difference is that delivery models, in delivery models we take more participatory approaches and contextualized approaches, speaking with people, and not only quantitative measurements of criteria. This is my impression.
One of the questions Kimon and myself were talking about earlier is the question of the levelized cost of energy, and whether that's the best metric to be using in the context of market assessments. Because often what we do is we consider the optimum systems, the best systems, and the best system is considered to be the cheapest system over the lifetime of the installation. And I think that ignores a lot of things that come out through delivery model assessments, you know, but how to include in that same metric, how to put a value on social empowerment, on the impact of the systems, both environmental and social and economic. I think that's quite difficult, but I think it's also quite necessary. It's almost a naive assumption that we operate on at the moment in saying, oh, well, it's the cheapest, it's the best, you know. So I think that is potentially an area of collaboration for the two groups.
Definitely, and I think we already have seen today some environmental and social criteria that have been quantified. Of course, there can be much more. I want to give the speech to Luis that raised his hand.
I think I was going to say that I disagree a little bit on Alfie on that thing about levelized cost of energy. It's a quite interesting metric because it allows for sensibility analysis, where you can vary a few variables and see how your levelized cost of energy moves up and down. And sometimes you can actually compare systems, and even if one is cheaper than the other, you can still make the choice to go for the more expensive one, because the more expensive one is not as much more expensive as you thought in the beginning, but you can still kind of fulfill your mission of your existence with that, you know, that kind of thing. So what would be interesting is to have out of the both delivery models and market assessment, I would say from the market assessment perspective is to find, to provide guidelines to integrate certain social aspects into the calculation of the levelized cost of energy. It's like, how do you integrate social impact when you're doing, you know, when you're calculating your discount rate, like, well, or just list typical discount rates for investment in different countries, that kind of stuff. That would be interesting. And from delivery models, what would be interesting to see is how does the fact that one system has been created somewhere that actually impacted the levelized cost of energy of any new system coming into play. Say you create a system, you deploy your delivery models, you make an impact assessment, and you have the possibility of kind of evaluating quite literally in terms of cost and risk. How does that fact that that community already have, or a community nearby, the one that we're considering already have an experience with the technology, that kind of helps you lower certain aspects of your calculation of levelized cost of energy. So that kind of a before and after, I think that's a quite interesting thing that could, you know, play for people, contribute for people who are doing more on the field.
Sure. Sorry, can I quickly come back on that? You're right in that levelized cost of energy can, you know, track the different impacts of different technologies and on cost and so on. But I think, excuse me, I think the more interesting thing is how people interact with that cost, how people use that energy, and the benefit of that energy to the people's livelihoods. So it's trying to bring in the impact as well as the cost, because in the levelized cost of energy, there is a cost benefit analysis going on there. You know, it's the cost of the system versus the energy that it's producing. But after producing that energy, regardless of whatever's going on in the system, it's like you're pulling up a drawbridge. You stop considering everything that happens after the energy is produced or stored as well. You know, it's completely agnostic to how the energy is being used. And I think that misses out quite a lot.
Sorry, can I shortly interrupt and say goodbye to you all? I think I can't follow that as an outsider of the whole system. But yeah, thanks for letting me part of it, and hopefully stay in contact. Thanks for bringing me in, Katerina.
Thank you very much for bringing us your insights, Larissa, and hope to hear more of you in the future.
Same. So have a productive time. Bye.
Goodbye. Good night.
Bye. Thanks.
I would just so to answer and to reiterate what I was saying before, is that it would be interesting then to see coming out of the market assessment and the delivery model working groups, methods and metrics that would help us work on, you know, assessing before we go into the field, but also assessing what's going on and how it evolves over time. You know, we here in Toulouse, we use levelized cost of energy throughout the lifetime of the installation to try to estimate the cost of expansion against connection. Say we try to use levelized cost of energy to simulate scenarios where the microgrid is going to expand until the point it connects to the grid. So if you have more indicators, or if you have a way of calculating how the fact that you've done a workshop, a turbine workshop on a certain community lowers the risk of investment in a nearby community, you know, that kind of stuff. It would be interesting to have that to help members of wind empowerment to, you know, write projects, convince public decision makers that whatever they're doing is actually driving in the good sense, you know, down risk and helping the local communities and the communities around the local community itself.
I think this is a very useful comment. And because this technology and this mode of production is so new, so alternative, it is not straightforward what kind of impacts it has to a community, to the existing situation. So yes, it needs to. I agree that it needs to be studied further by closely looking into such examples.
Yes. Can I add something?
Sure, Guy.
No, I think that I think that the relationship between the market assessment and delivery model would be great for a organization that want to do a project like we say like a consultant activity before to do the project. I think that between the market assessment and the delivery model, we have a kind of master plan suggestion. And I think that it's very important, for example, is related with the question that John did to me about if and Luis also, if we have a model, for example, a co-management model that it could be a community model. Well, for example, that can be, but that gonna be take a lot of time. We have to consider a lot of things. So I think that we need to know that to take strategy decisions. So between the market assessment and different kind of delivery models, we can know, you know, for example, to do a plan for, I don't know, for 4 or 5 years. That would be great, I think. Very useful for a member organizations. I'm thinking in a very practical way. For example, well, I'm 500 RPM. A Wind Empowerment. I would like to do a project, I don't know, in Peru. Well, okay, let me know. So if we have the market assessment tool and the delivery model tool, we can say, yes, 500 RPM, you are in a good way, or it's not good if you are gonna do development project over there because, or you have to take in account that you have to consider 5 or 6 years and a lot of money to do it. It's better if you start with a course or something, or demonstrative project. I think that could be good to take strategy decisions, I think.
So just to come in on that, one of the things I've added on the from the page here is at a high level, we need to think about the feedback between the MA and DM groups. Because obviously the market assessment group uses knowledge produced by the delivery models group and vice versa. So it would be good to think about the processes that we go through in the market assessment and where, you know, at which points the delivery models group can feed into, and then vice versa, at which points in the delivery models processes and the methodologies is information that could be produced by the market assessment group important. And then I think if we start to map that out, I think that can better define how the groups relate to each other. And potentially even, I mean, this is very blue sky thinking, and you know, but potentially having a holistic methodology that combines both, all of the above.
So just a comment on this, Alfie, is that even if some topics were presented today inside the delivery model session, it doesn't mean that they are more related to the delivery models than they are to market assessment. For example, life cycle assessment, it can largely inform the market assessment, I believe, as adding additional criteria, environmental criteria. So yes, they are overlapping and the border is not defined, but the purpose is not to divide so much, but yes, to maybe to have a comprehensive tools to assess should I say sustainability in the end of different technologies. Yeah. Viability is also a matter of sustainability.
I was thinking it was mad that so my initial comment about levelized cost of energy, that is the main metric with the only real metric that we use, well, not the only, but the main metric we use in market assessments. And obviously there are so many other metrics coming out of life cycle assessments and so on, that should also be considered at exactly the same time as a market assessment. You know, you say there is a market of this many people in this area. This is how many wind turbines are needed. This is how much investment is needed. This is how much investment is needed over a certain number of years. But in the exact same line of thinking, we should be thinking about the outputs of the life cycle assessments. You know, if there are this many wind turbines of this size, what is the environmental impact on that, of those? What is the social impact and so on? So, you know, there is definite things that can be incorporated and shared.
Yes, agreed. I want to give a speech to anybody else. Yes, okay.
Yeah, I try to make it quick as always. The thing is, so the way I see it, as not being somebody who does market assessment or delivery model studies, is that the market assessment provides us with tools that makes us, you know, help guiding the fundamental question is, should a wind turbine or system be installed in a given place with a given group of people and a given social condition. So it allows you to study the environment around the thing. And it will never give you a totally black and white picture, except where there is absolutely no wind. But if there is some wind resource, you know, there's always some gray area. And that's where the delivery model comes in, is in saying, okay, if that gray area is to be exploited, how do we do that? And the delivery model provides you with the tools of assessing what kind of relationship, technological and socially speaking, you can establish with the local stakeholders so that the technology, you know, maximize the lifetime of that installation and obviously the impact that installation will have in the local livelihoods of people. So they're very distinct objectives, each one of them, and they're interdependent, because if you do a bad market assessment, you have bad input for your delivery model and so on. But I think we've done a lot of work on that, on establishing the tools that allow us to analysis before we start. But we have not done a lot of work on, you know, trying to get the feedback and building. I mean, John has done that in Scoraig. Maybe I'm wrong on this, but I have the feeling that we have not done the sort of following up on you do the market assessment, the delivery model in the beginning with that bunch of hypotheses and so on. And then you kind of have a tool to observe and watch the impact assessment of that over time as it evolves. And that could be an interesting thing coming out of this collaboration, because then it becomes a real collaboration. It's really something that both of working groups can work together, you know, kind of how to observe the system and provide people with the feedback that they may need in order to, you know, react to problems that they're facing in the field on the daily issues going forward.
I remember some work from John, Leary, on the monitoring and post-assessment, I think, of small wind turbine projects. There was definitely a research paper about this. Am I right?
Yeah, there was a paper on post-installation analysis of some of WindAid's turbines in Peru, just seeing what had happened to them since they were installed. Like, firstly, were they even still working? At that time, that was the main question. And I'm sure there's a lot more that could be done in terms of what impact have they had for people? I mean, there's been a lot of work done looking at what's happened in Inner Mongolia. Alfie, I know, has done some of this work, and also there's another colleague, Simon Batchelor, who did a study way back in 1999 looking at what the social impact of small-scale wind power has been in Inner Mongolia, where there's over 100,000 small wind turbines, or at least at that moment in time there were. So I really think there's a need for many more of these kind of studies of looking at what has the impact been of small wind turbines, and how could we either refine that over time, or how could we look to adapt these systems, as Luis was talking about the evolution of systems. Then in some cases it may be that adding solar to a system, a market assessment for small wind systems where solar could add extra value, maybe another way that the market assessment team could focus their expertise. I guess you could also look at repurposing small wind systems, so small wind systems that already exist. Then are there new energy services that they could provide that would increase the viability of those systems in terms of the energy that's produced, making it useful to people?
Just as a, I forgot to say this, but just as a feedback, we did a study where we had a load flow system that calculates, the distribution of power in a small microgrid. In this case, it was not really a microgrid; it was just PV and input, an inverter, and a load with some batteries. So really like a household and a solar home system. And we did that calculation to kind of like size the system, and we used the results of that sizing to put into a cash flow to calculate the levelized cost of energy and so on. And we did a few hypotheses on if we add more PV or if we add a wind turbine, and we kind of tried to see on the long run how did that levelized cost of energy evolve over time. If you guys are interested, I can show you that some other someday. That tool and the kind of analysis we did. And this is quite interesting because it couples a technical analysis with an economic analysis. And it can be, you can always add more variables in. It could be an interesting tool to start from and build upon.
Sure, maybe Luis, you can share it with us later, also on the Discord channel.
I will.
Okay, thanks. Maybe somebody else wants to make a comment. It seems we have a lot of notes on the board. Definitely something to reflect on later also. Okay, what do you think? Should we end it up here because we have run a bit late?
I'm quite happy. I've ideas in my mind. I'm also very conscious it's quite late for you, Katerina. It's quite late for me, but it's even later for you.
Me, I'm okay. I can handle. I'm not sure if we have anybody who is more east than me, but maybe not.
It looks very late where you are, Alfie. It looks like you're in the twilight.
That's because I'm in Glasgow.
But Alfie, you can go on if you have something to say. I thought you said you have many ideas to share, but maybe later.
No, my ideas are all on the
perfect.
all on the screen now.
Okay. So I hope that this joint work here that we have produced can be useful to the next members of the working groups as well, to design the future of the working groups. we can arrange maybe a follow-up discussion sometime later after we take a further look on these comments. And we can also continue the discussions on the Discord channels, of course, the delivery models, the market assessment channels. So if nobody has another comment, I will propose to...
I do, before you finish everything.
Of course.
Do not forget, we have a book to write. We have a book to write. WindAid is writing a book. And if you look at the, I'm gonna paste in the chat before everybody leaves, but it's already, I'll paste it also in the Discord, the Excel spreadsheet where you can kind of look at the different chapters. Some of you, Katerina is already part of the book, and some other people who are already in the market and assessment and delivery models working group are part of the book. They're writing some chapters. But I invite everybody to take a look, see if you're into whatever you're interested into, you want to contribute to that book. It's going to be an interesting collective endeavor. And the more we are, like we say in France, is the more crazy people we are together, the more we laugh. So I really invite everybody to take a look at it, see if you actually feel you can contribute as an author to the book. You're more than welcome to join. And if you think you can be a lead author in the chapters that are missing lead authors, please let me know. I'll be more than interested in having a word with you. All right.
Luis, we have a new deadline for this, right? Is it end of next year?
Sorry, say it again. Yeah, the deadline for this book is end of next year. So after the conference, I'll have a rough list of people interested in some lead authors. I'll probably have some missing spots. So what I'll try to do is organize a Discord meeting with everybody and see if we can designate voluntaries for the book, for the leading authors.
Great, great. Thank you, Luis. So I want to thank every one of you, the panelists, for joining and presenting their work, and all the participants, especially those that are still with us. I hope you enjoyed the session, and that we will have a chance to continue these discussions on Discord. So good day, good night to everybody. Mostly good evening, good night, I would say.
Thank you very much, Katerina, and thanks everyone.
Thanks, Katerina.
Thanks, Katerina.
Thank you.
Good job.
Thank you. Thanks, Katerina, and for everybody. It was a pleasure to be here.
Igual.
Thank you.
Okay, bye.